Okay. So, in the tradition of Smart Scarecrow pushing the wrong buttons, I would like to invite everyone and welcome everyone to a very special Saturday afternoon live broadcast from Zero Fossil Fuel and Zero Labs. Today we have with us Mark Dansie. Please stand by.
We need more volume. I'm getting messages from other people. Hello.
All right, so without any further ado, let me bring my feature guest in here and see if I can get this done right. Mark Dansie, how are you doing today?
It's great. It's about 11 o'clock at night here, but at least the roosters aren't crowing, so we should be able to hear a few things.
That's good. So listen, the reason I brought you on here today was to talk about the new Kickstarter campaign that you've got going on for the Hydra-Light, and some of the projects that you've got going on are all built around that. You were showing me some circuit boards earlier. I thought those were really cool. And yeah, there it is. There it is. The realization of a dream.
Well, yeah, it's been a long history. You used to talk to me in Utah when I was based there researching some other technologies, and we started to play around with this little project. And my vision always is to bring cheap, sustainable lighting to developing nations, especially people who haven't got electricity.
Right.
But we've actually ended up with quite a few products and developed the technology further. I was showing you this before. This isn't released yet, but this will be what goes into it's a downlight that will hang into the huts to replace kerosene lighting.
Right.
And I'm very, very proud of this one. It's very, very simple. It's just got a power cell, as we call it, in there. And I don't know how clear the video is, but there's the power rod that goes in, and that's the consumable. That's just a metal, and that gets consumed. And that one there is about nearly 100 batteries, about 85 normal AA carbon batteries value. So the idea is to bring something to them, and we have two models of that. One will be just as a light, and the other one will have an internal rechargeable battery that will get charged up by the cell, and then that can give a brighter light or charge a cell phone. But I hope to get that out in the $10 to $20 range to the third world, which is about what the little solar lamps cost. But this one's about 3 times brighter. But however, I'll go through the products a bit later that I showed you. I can't show you everything that's under development, but I think the journey, as we remember started with something like this all those years ago. I think I was on Smart Scarecrow, and I just, had the old flashlight, the one I couldn't shut down. I'd fill it up with water, and
Right.
there we go.
It was actually running off, as I recall, the humidity in the air that you had there.
Yeah, I don't want it to do that, but it does do that. There's a lot of reasons. But we're developing, the flashlights will come later and be released, and people will see the products. This is an early prototype. They will see the products like that, and there'll be other products like I'm not supposed to show this one, but this one, this is the Twin Tower lantern. This is the Bertha Butt. It's the only twin towers I've ever seen. This one has 2 cells in, so it will have a lot of power for recharging batteries and that. But this will come out later in the year.
Right.
But that's a prototype, and it's pretty damn bright when you put 2. This one hasn't been chromed, but it's pretty damn bright. So we're bringing out a series of products. Some are for the developing nations, and the other ones are, like for the camping market. There'll be radios, there'll be flashing Christmas trees, there'll be marine lights, marine safety lights, The list goes on and on and on. I think there's about 18 or 20 products. We've probably got 6 close to finalisation now. But at the heart of this is the technology. And what we've got here isn't a normal battery. It's more like an air cell. So if I get 2 dissimilar metals and I place them in salt water or an acid solution, you'll normally find, especially if it's in like salt water, you'll find that initially you get a reasonable amount of power out of it, but then you see the power dropping as it oxidizes and the oxygen drops out the water.
Right.
So it will find a floor. It will drop probably 70%, maybe 60%, and then it finds a floor. This one's the opposite. It breathes the oxygen from the atmosphere and allows it to be part of the process, and it actually increases in power. So when you first turn these things on, it's a bit like an old valve radio. If you just got the water only mode, it takes a little while. It comes on straight away, the light, but it really takes 1 or 2 minutes to reach its full intensity. And what you actually see is it's climbing. The actual power is climbing, and then it hits a plateau. I don't know what's happening there. You're scratchy.
Oh, okay. Yeah, I moved around with my microphone for just a moment here.
Yeah. So what we're trying to do is we're trying to get, I can do a conventional battery using just 2 dissimilar metals, but I need a huge battery. It'd be like to get the same as one of these little cells. I'd be looking at, a battery 5 times the size of that. So we're aiming to get the maximum density. And we didn't really invent something here. We adopted something. We adopted a technology used in the military and from the past and some expired patents. However, we're taking it to a whole new. The first product range will use existing components that by a manufacturer that supplies for military applications. But we've also been working on developing the cathode ourselves, and I was in the UK at Cambridge last week working with a spin-off company, and they still lecture, some of them, at the university there, and we're developing a whole new cathode that I can't actually talk about it too much, but it'll be like a fraction of the cost and it'll be mass produced. So I could virtually turn a shopping bag into a very powerful fuel cell. As simple as that, with a bit of metal in there and a bit of salt water. That's where we're heading.
Wow. So
the
development has not stopped, and you're probably married to this for life, right?
No. I've got other projects I want to do. I think we're talking before when everybody's listening. I want to do a 20-year flashlight that doesn't go off for 20 years, or an Orbo that really works. I've got 2 or 3 other
powered by 2 ever-ready Energizer 9-volt batteries.
No, that's for voltage reference only.
Yeah, right.
You must remember that.
Oh, okay. Yeah.
However, I'm not going to talk about that now. So the journey started, I was working on another project in Utah. That's when I used to bug you about doing buoyancy experiments. Remember that?
Oh, yes.
Do dumb.
I still have it on the shelf.
Oh dear! Don't do an episode about that. That was my dumbass moment. But we were looking at building. I was working with a team that were working on materials that continuously generate electricity, and they can be made, but they're very, very low power. And somehow or another, we're just mucking around, and I got onto this project. When all the other stuff went belly up, we're left with this. So I decided to come over here. We have it's really an international collaboration. We have my little lab here, and we do the prototyping here. I was telling you before how we do a crude 3D print like this, very crude. I don't know if you can see that yet.
Oh yes, that comes over real nice.
Okay. And then we go to what we call silicon molding. So we can then take the 3D print sandpaper, get this rubbery silicon stuff we pour around it, make a 2-part mold, and then we can pull out prototypes like this that's very close to the final product. We pour in a resin into the mold, and the mold's very flexible, so you can actually release it. It's not like, injection molding. And we can pull quite a few prototypes. And then from that, once we're happy with it, we go to tooling, and this has actually been injection molded, these components. It's not the final finish on it. This is the first drafts, just to check everything's okay. And that's our process. But we have a team here that do, the engineers do, we have a really talented artist and designer in California who comes up with the concepts and the actual initial shape and designs. We have we had all the electronics, and I showed you some. This is for the big cell. That's one big lot of electronics.
Yeah, it is. I was really surprised at how complicated that electronics package was. I was expecting maybe a chip and a few discrete components, but wow.
Well, that's for the big double tower cell, and that does several things. It not only powers the lights, and it can power the lights either with a battery or with a water only or combination. It's also running accessory light. It's also managing the cells because they're a bitch to manage. And it's also doing the output for USB. So, and the guy who designed this simply was the best in the world. The efficiencies he's achieved, that's the late Marquis. I won't say who he really is, but we all know what he used to do in the forums. But he designed a whole series of boards. This is what's in, this is the size board that's in the lantern you saw on Kickstarter. And this one's for the downlight. We mount the 3 LEDs on there for the downlight, but it's the same board we use. And this one here, there's 2 versions. There's one that's stripped down and it's just a DC-DC converter. And the DC-DC converter on these, your typical one in a Chinese torch is about 60%, 50%. Good quality product, 70. This thing pushes 85 and tops out at 93% efficiency, which is unheard of. Nobody's ever heard of those efficiencies before.
So this is not your typical buck type converter. This is very high efficiency.
Oh yeah, this is more like the $3 or $4 converter. We do have a small one. It's costs us about $1.30 to make, and that is between 83 to 93% efficient, depending on what the application is. And so we had to get that efficiency. We wanted the brightest light, and we wanted to extract the most we could from the cells. The other thing that went in our favor is these little LEDs. I'll show you a comparison actually. This is a standard LED.
Okay.
You see the difference in the brightness?
I see the difference in the wavelength as well. The brighter one is actually more of an incandescent type. It's
cooler. I've got a cooler Kelvin. That's a 57 Kelvin. This is probably a 65.
Right.
But this is, I'll give you the difference. This one here that's been used in here, and we trial a lot of them, that's probably about 65 lumens per watt. Okay, that's how they measure the efficiency.
Okay.
This is 170. See
per
the
watt?
Difference? Per watt. When we started, the best we could buy was 120. So suddenly we've gone up and getting a lot more light out with the same amount of electricity. So both these lights, for instance, this is part of the history, both these lights are being powered. It's back to front when I see myself.
Yeah, I know. Isn't that tough?
I'll stand on my head, that'll help. The one, I was going to say the one on the right and the left, but I'll just say the bright one, that's using the latest, most efficient LEDs. It's drawing no more power than the one on that's not so bright.
Right.
Okay. So we had 2 things in our favor. We had the LED technology improving through the roof, and secondly, we had a designer of the DC-DC converters go from 50 or 60 up to 90. Then you add the LED improvements, and suddenly we got something that's really, really world class. And that's why, I welcome a lot of competition. A lot of people will copy this technology.
Sure.
But it will keep us ahead of the LEDs are available to everybody, but electronics, managing that cell, that bigger board, if you really knew what it did, there's 1,000 lines of script in there that just manages the whole operation. And we have these little indicator LEDs, and it's telling you, it's having a think now, it's going to do this. So it maximizes the maximum charge out of the cells, and it maximizes the performance of everything.
So there's a certain degree of intelligence built into that board.
Yes. This one's a bit more dumb. It hasn't got any program. It's using this one charges up a battery, but it's not using a chip to evaluate the battery's condition. It just hits a voltage and says, you've had enough, and cuts out.
Right.
So we go from very simple, I didn't bring the other one, we go from very simple little one the size of a postage stamp to this, to the big, and there's a couple of years development in all this. The debugging was huge. We're still learning a few things about these, but that's where the development went. So to do this project, I guess what I'm trying to say, Mark, is we applied the best technology, electronics, the best LED technology, and the best cathode and cell technology we could get our hands on in the world, because it's the only way we could do this. And the reason other people haven't succeeded this or done a very good job of it is it's so hard to do. It really is hard to do. Not building this. This is easy. Building the actual light and the housing, the LEDs, that's all easy.
Getting it to market.
Getting it all to coordinate.
Yeah.
And then where I'm most excited is the cathode is very expensive. It's $1.50, $2 just for a little piece of cathode. We might be able to make those for 20 cents. We're already testing them. In fact, when I left the lab tonight, I had a big smile. I come back from the UK with the latest samples, and the lights were on, and it was the LEDs just glowing. They've been glowing for hundreds of hours with this cathode that I just picked up from the UK, and it was, it's a fraction of the cost. So that's where we're heading. Our first production runs aren't using that.
Same material or a different material than what you're using now?
Totally different concept of how to manufacture.
Okay.
What I found was with the cathodes, if I go to America, Israel, China, they all copy each other. They're all saying, we've got patents, we're all doing this, blah, blah, blah. And so it's a freaking same cathode.
So that's the cathode, not the anode?
Yeah, the anode's simple. That's metal. That's just magnesium, aluminium, zinc alloy. Okay?
Oh, the cathode is what lines the container.
Yeah, that's what sits here behind this screen.
Got it. Okay.
Okay?
Mm-hmm.
Okay? That's what breathes the oxygen. Okay? So the cathode's metal. This is plastic and carbon and a few other bits and pieces. Okay? This breathes. That's plastic there. You can't see it. I didn't bring a piece of cathode.
I wasn't aware that it needed to breathe.
It has to breathe. If I just put two rods in there, you imagine that's, say, zinc, and I put coppered rod in,
yep.
The power will drop because it will oxidize in the water, and you'll see the power drop. But if it can breathe, and it does, it breathes a hell of a lot of oxygen, then it can increase in power. So we get 5 to 10 times the energy density than you would have with a normal battery. With a normal, water battery, putting a bit of salt water, copper and zinc and magnesium. You've seen those over the years. And they normally get 20, 30, 50 milliamps, something like that.
Yeah, at best.
For a single rod. This pumps out 1.5 amps if we want it to.
Wow.
Okay, but we don't run it at that.
No, obviously, but wow.
So, it's pretty damn powerful. We run it typically, because of the LEDs now, that LED that I showed you, previously you would have had to draw probably 1 amp to get that brightness. Now you can run it at 200 or 300 milliwatts, and you get the same brightness as what just last year you were getting 1 watt from.
So
So
when the lamp is operating, about how much current is it drawing from the battery?
this product here, which you see is very, very, very bright,
That's your
I'll put it
downlight.
on my head. Yeah, see the downlight?
Yeah.
This will light up at, a kitchen table, a desk, very, very, very brightly. That draws only 200 or 300 milliwatts from the cell.
Okay, milliwatts.
Yeah, it draws. I always put see, there's a few little secrets to this I can't tell you, but if you get one of these cells and it's open voltage, it's probably be 1.6 volts, 1.7 volts. But we actually alter the voltage, it gets drawn down. But when I talk about it, it's volts times amps, that gives you milliwatts, okay?
Right.
So I'm normally talking milliwatts because we don't draw at 1.6 volts, we draw at a different voltage. And I can't give away some trade secrets, but it took a long time to find them out. But we draw down, the board forces the cell to do things it doesn't not naturally want to do. Okay? It's a bit like harnessing a horse and saying, do this. I don't want to do that.
Okay,
Yeah,
so the voltage on the battery fluctuates, but the electronics keep it steady for the load that's on the other side of it.
Yes, that's one thing. It also tells it what voltage we want to draw from it.
Right.
And that increases the current you can draw.
Got it. Okay.
There's a sweet spot for these cells, and we work at the maximum sweet spot. It took a long time to find that sweet spot.
I'm sure it did. That's a lot of R&D.
So we have the team here that does, I got a little technician, we got a engineer who does all the drafting and drawings. The manufacturers have got really good engineers, production engineers who design the tooling and help with advising on sealing and that. And the hardest part of this is trying to find the right manufacturers and learning how to deal with China, learning how to deal with here and other countries that are involved. That's been the hardest challenge because when you're in Asia and even some other countries, when they say yes, they don't always mean yes. Yes means no, or yes means I don't understand, but I'll still say yes.
Wow.
But now I'm with a group of manufacturers who really know their stuff, and we're still using the original one.
All right.
So that's the technical side, if you like. If you want to throw up that slideshow, we'll go through that quickly.
That's what I was just going to suggest. So I'm going to bring up the PowerPoint presentation that you gave us here. And
I can slurp on my coffee.
We'll just start this by doing this, and I'm pretty sure.
Yeah, go to the next slide. That's some of the products. You got I'm not sure it's left or right on your screen, but the small one is the downlight,
right.
And that'll come in 2 versions. That will come in, that will be available for the first world, and I don't know what the price point will be. I'm not allowed to. It'll probably be under $20, and that can plug in another accessory light, which you'll see in the video of the products in the Kickstarter. But that one's for the third world or the developing nations, and that will come in 2 versions, water only, and it's just a water lamp. And the other one will have, more expensive one, will have a USB output and an internal battery. So even if the water cell's not in it, if the internal battery is charged up, it will still operate.
Okay.
So that's for emergency standby. So if you're fiddling around in the dark, you can switch it on, then go find the tap.
So this is
second.
This is your big
These
Bertha.
are old. Yeah, that one there is an earlier version of this. It's a different style, but it does the same thing, different LED configuration. These are old drawings, by the way. I found this presentation in a hurry.
Oh, I see. You had the LEDs on the bottom
tape
facing up, and then it was reflecting to the side off the top reflector there.
Yeah, we may actually, in production, some people have asked, these things can, well, you've seen it's a tower. We may put a diffuser on there because this gets, bleh. all the manufacturers, you guys are old-fashioned. I said, I'd like to blind the shit out of the people, but at least they know it's working. And they no, put a diffuser. Well, put diffuser. Everybody use diffuser. Oh, okay, whatever. So there might be some minor changes. Then the other one is the big double one. That will come out later. That's got twin towers. And the one you've got in the drawing there hasn't got the twin towers. That was reflected.
Yeah.
But we've gone to the twin towers. So that's got USB output. It also has a DC jack for our accessory light. So you can have the lantern going. All the products, everyone, including the water only, come with a separate little down light. And you can hang that in the tent and that. You'll see that on the Kickstarter. So go to the next slide. Don't worry about this one.
Okay, here's the Hydra-Light energy cell.
Okay. I haven't dissected that. There's still some... there's a lag here, by the way, folks. It takes about 20 seconds for the slide to come up.
Yeah, this is just the picture of the one cell with the description.
Yeah, so you pull the rod out. Now, here's the deal with this. If I wanted to, you see 200, 4 hours continuous. If I put more metal in there, I can get 500 hours. I could get 1,000 hours. But we had to pick a level that everybody was happy with, including the distributors and the shops and that. And with this technology, the storage relates to the weight of the metal, okay? And here's a simple formula, which is very, very convenient. It works out per gram of material. I don't know what that is in ounces. It's 28 grams to the ounce. Per gram of material stores 1 watt hour. Okay? So 1 watt hour of material, if you put a 100 gram rod in, you get roughly 100 watt hours. That's about 30 alkaline batteries, maybe 40, or that's 100 AA carbon batteries. If you put a 300 gram or 500 gram, you're storing half a kilowatt. Now, here's the downside. You've got all that energy there, potential energy, I'd call it. So we can store, you can run the light if I wanted to for 1,000 hours. We've run these things for 1,000 hours on a single piece of metal, using more metal. But you can't access a lot of power quickly. So we run them at, around about 300 to 500 milliwatts. But the point is, with a normal battery like a lithium ion or a carbon cell, you can suck a lot of power very, very quickly.
Yep.
And that's why if you're not using it for water, if you just want it for lighting or power your radio, I ran a radio for 3 months without turning it off on one of those rods. If you run that, you get very, very long life. If I put a kilogram in there, we could run for thousands of hours non-stop. But the point is, you can't draw down on it like a normal battery. So that's why we brought out the hybrid model. If you want to charge your cell phone up in an hour or two or however it takes, we put a lithium ion battery in there so the cell charges that, then you dump that to your phone. If we're connected directly to the cell, we can't pull down the amount of current you need to efficiently, or not efficiently, to fast charge it. You might sit there for 12 hours. So that's why we brought the hybrid. So if you're using just water only, okay, if you just use water only, guys, it'll last for a long, long time. If you want to charge anything with it, or get a super bright light, that's the other thing. We combine the water battery with the other one and get super bright light. Then you have to have an intermediary battery. So the good side is it's many, many, many times the storage of any battery, but the downside is you can't draw a lot of power really, really fast like you can with a lithium-ion battery.
And that super
if that makes
bright
sense.
That super bright light is relying on the charge that's been stored in the lithium-ion battery.
No, this one here is pure water. There's no lithium-ion battery in this.
Okay.
Okay. This is the water only. But if I put a lithium-ion, the hybrid model, you can switch, or if you like, we got 2 modes. You can have it water only, which is plenty bright enough. Just look around here. I'm in a bright room now. But if you wanted to, you can switch it and it'll run off the lithium-ion battery. And you can even get it brighter, though. You'll probably, we got it limited, otherwise you'll blow the little LEDs up. Okay, so the only reason for the model with a lithium-ion battery is to actually, I nearly called you Gary. In a long time, Mark.
That's all right.
So it's only for charging cell phones and that. We wanted that power available so you could rapidly charge something. Okay, but the consumer gets a choice. This is the cheap one, water only, nothing else but the cell and the board. Okay, that's it. The other one has a more complex board and has the ability to recharge a phone. So the base model doesn't have USB on all the products. The expensive one, or the grade up, has a lithium-ion battery and a USB. I hope that makes a bit of sense. Keep going through the slide. Oh, you're going through the slides.
Yeah,
just flip up a couple more. Get to the ones where it shows you the difference of energy storage. Questions? I've been doing a monologue here, mate.
Yeah.
There's a typical configuration, the supercell lantern, which isn't released yet. That there, you can have an accessory light, hang it off your ceiling. You can have your main light, and then you can charge up a phone all at the same time. So it's really a little portable, if you're camping and that, it's a little portable power side, I guess.
Now, what do you think something like this will retail for? Ballpark.
I don't know yet. I really can't tell you that, but I get in trouble every time I mention dollars, but depends what country you're in. But
yeah.
It's not going to be through the top. The third world countries, here's the deal. If you're retailing in America and that, whatever we sell it for or a cost to manufacture, you've got to multiply by 3 or 4 because everybody got to get their cut.
Right.
Whereas if you're in a developing nation and you sell something for $10, it's only going to be 20. Or if you sell it for 5, it's going to be 10. Whereas if it costs you $10 in the West, it's going to cost you $40 in the retail. So when we did our Kickstarter, because it's in the West, we had to put it at the prices that the retailers would sell it. We're not allowed to undercut the potential retail price.
Yeah. Now these flashlights that I have up here, these are also air breathers?
Yeah, they're not the actual final product. It will look a bit different. They're still developing the final prototypes of that.
Okay.
That will come in 2 models. Yeah, they're early drawings. They're concept drawings. They all breathe air. See the holes?
Yeah. So
that breathes the air.
Those really are the air inlet for the cell.
Yeah.
So that actually then that precludes these from being used underwater. Yes?
Yes.
Okay.
Yes, but we will bring a model out of diving light eventually. We know how to get around that.
Huh. Interesting.
But that's not going to be like the engineering that goes, the cells that go in there. Here's the other thing you have to do. Not only do we have to breathe oxygen in, we got to vent a little bit of hydrogen out. Okay?
Okay.
Not enough. You can't light it up. It comes out at a very, very small rate. I'm looking at the slide now. See that power rod there? Say that's 300 hours.
Right.
Well, that's your comparison if you're doing a 250 milliwatt load. Okay, with standard AA carbon battery, you get 4 hours. With an alkaline battery, and we're being generous here, you get 10 hours. With one of our power rods, we're getting 300 hours. But if I bring out a fatter carbon rod, power rod, that weighs a bit more, it could be 500 hours or it could be 600 hours. Okay?
Yeah.
So that's just a comparison between the storage, the energy storage. I think I'm 20 seconds behind. If you flip to the next side, you get little battery graphics.
Yeah.
Yeah. So what we did there was saying 80. So that's your power rod. One of those is equal to that many other batteries. And the bit I didn't mention is the other criteria I set out to do from day one is batteries are bad news in landfill. And people camping and that throw them on the ground of the trails, and they're really bad. I think there's 180 billion batteries a year or something in the US. It's a crazy figure. Gets consumed each year. It's got lots of nasties in there. What we've got, the simple metal, that rod disappears. As it gets consumed, I kid you not, it disappears to where you'll see nothing except a toothpick at the end of a rod. That's an earlier drawing of the lights, by the way.
So
what you end up with nothing in there. You end up with a little bit of plastic you put in there to start with. It gets totally consumed.
So it actually turns into gas and vents off?
It turns into two things, gas and another stuff called magnesium dioxide, which is pretty harmless.
Mm-hmm.
I think it's what milk and magnesia is made of or something. It's considered benign, to the environment. The only bad thing is if you tip it out, you can tip it out in the garden and act as a fertilizer, but you've got the salt in with the water, but you end up with a sludge, and it looks a bit like, one of the reasons the water's there actually, how I talked to that one that runs off the humidity, that was because we never had enough water. The water acts as a waste management system.
Ah.
So the water gathers the sludge, it settles at the bottom, and then you flush it out, put some fresh water in. Now, if you let that water dry out, it creates an ion bridge, and that's when you get the Jesus light running off the humidity. I couldn't turn it off.
The Jesus light.
So what you have is the water actually acts as the waste disposal, so the sludge comes out, and it's very benign, and it's not going to hurt the environment anyway. And when you look at a little bit of white sludge versus 100 batteries, I'll take the white sludge any day.
Sure. All right, well listen, Mark, that was a great presentation. I want to take some questions from the chat rooms. I see about 22 people watching right now. Hopefully we'll get more than that watching when I put the recording up. But if there's any questions that anybody has for Mark Dansie, now would be the time. I'm going to try and scroll back a little bit, see if I can find anything here. Talking about coffee. In Asia, yes means I hear you not. Damn shame dealing with China. They will steal everything.
No, they won't steal anything. It's a little bit more advanced. The Indians are stealing off the Chinese now. So the Chinese are saying to the rest of the world, the Indians are stealing our IP and we care. But China is a very sophisticated country. I was in the city the other day, a city called Ningbo. It's up near Shanghai. And I was saying to the person I was in the car with, I could be in a suburb in California. They've all got nice modern cars, beautiful freeways, nice apartment blocks, big malls. I said I could be in any modern city in the world. And they've come a long way. They really, really have. And the manufacturing has too. A lot of the companies are very, very sophisticated. The local train service runs at 300 kilometres an hour. And that's impressive. You catch a train there and you get up to just under 300 kilometres an hour. But it takes a lot of time. Finding the right people to act as your eyes and ears and your guide in China is very, very difficult. And we're fortunate now we have got a good team and we've got some pretty good manufacturers, but that took us nearly 18 months to work through. And the original manufacturer is still going to do a lot of work with them, but the right manufacturers, we've got the right skill set. I could write a book about that. It's just daunting to do it for the first time.
Yeah, I'm sure it is. A big large learning curve. So Shubis says he'll take 2 of the hybrid models. So Shubis, go to the Kickstarter campaign and you can pre-order some for a discounted price right now for a short while. Preppers are going to love this, probably. Tell us about cleaning and rod replacement.
Yes. Look, you can run this cell for uh, you can run this cell probably runtime. This is actual burning, doing the actual light running, 30, 40, 50 hours, and then you want to tip it out. Because what happens is, I don't know what you can see, but the sludge just keeps building up slowly inside. The actual final cell that comes out will have a little window, and you can see that. So where it goes up to white, that's the sludge. I've run them for a couple of 100 hours without cleaning them, but I don't recommend that because if they dry out, they're a bitch to clean. The cell replacement, the rod replacement, you just pull the rod out. We got the little video on the Kickstarter campaign, click that on. All you have to do to replace the rod is throw the old plastic holder out and put a new rod in. It's as simple as that.
Okay, I'm going to make sure to put a link up to the Kickstarter campaign in the recorded
Yeah, there's a
video.
video there, a little 3-minute video, and it's just simple. Pull the rod out, throw it away, grab a new rod, put it in, lock it in. But we've also made, that's the disposable. We also made the cell as a disposable spare part because here's another little interesting quirk about the technology. If I run this every day, it'll run for literally years. I ran them for months and months. But if I took them through and I drained them out, washed them out, drained them out, which you should do if you're not going to use it for a while, because you can get a little bit of corrosion of the metal in the salt water. But if you do that, these things after a while do drop in performance for the cathodes that's in there. It could be 1,000 hours, could be 5,000 hours, could be a few hundred. But if people don't look after it, then you're going to have to replace the cell. So this cell itself, the anode, you go and buy in the blister pack at the shop, whatever, like a battery. But this will also be available as a spare part. And all those clever people in the room eventually have figured out, okay, I can buy a cell and I can buy one of these, and they're right. They got a little power pack. Okay. But you really, and it'll do things. You can put a normal bit of electronics, you can power LEDs. You can do that with this. So the other reason we made this available as a consumable as well, somebody might go and ram a screwdriver in there, or don't look after it, or don't wash it, whatever they do, Zero, rather than have to throw the whole product away, we thought we'd make this replaceable as well. Because I'm not trying to say this in a bad way, but if you go to a little village and they're relying this on a lot as for their light, and it means a lot to them, kerosene can be 30% of their income. This thing will cost them only 5% of their income to run. They're going to look after this every day. They're going to wash it. They're going to love it, and all the rest. If I take it to a certain developed country, people are lazy. Throw it in the cupboard. Don't worry about it. And it could damage it if they don't maintain it. So we had to design against sloppy, slack people who don't maintain things.
Right. Okay.
Does that answer the question? The rod's very easy to replace. Look at the video on Kickstarter.
Yeah, I just put up the link to the Revolution Green page, and I need to bring that in here.
You also got a Kickstarter link too. You can throw.
Well, they can get to the Kickstarter link from the Revolution Green page.
We did the Kickstarter for two reasons. One was awareness, and I think that's important always. This has been an expensive process. I've got sufficient funding to do things, but just tooling for one of these, what I just showed you before, the few products, you're talking 200,000 or 300,000 in tooling. Expensive. So it takes a bit to tool up, and as we're going to release another product probably on Indiegogo, the Third World one. That will be for people to sponsor. If they want to sponsor a light for a hut or a 10-pack for a small village, that'll come later in the year. But the Kickstarter, the funds from that will help with the development. The cost of developing these, I think, when we thought we weren't being heard before, that board that I showed you, that's over $100,000 US to develop, and that's big bucks. and we're not rich. I can assure you, I'm not rich. That's one reason I live in the Philippines. One reason we got our lab here, got brilliant staff. It costs a fraction to run a development lab here with all the prototyping and all the rest and experiments. I wish I could have shown you it tonight. You see one room's just full of cells, dozens of cells being tested. In other rooms where they do the 3D printing and engineering, in other rooms electronics lab. But to run that operation in the US would cost tens of thousands per month. Here, it doesn't. It's as simple as that. It's economics. Plus we're close to the manufacturers.
Cost of living there is also quite a bit less too. So the the whole income structure is at a lower level.
Well, I got most of the people who are working with me, got college degrees and that, and I'm paying them extraordinarily well to what they normally get paid here, and I'm paying typically, trying to do it in US dollars, $300-400 a month, $500 a month.
Wow.
Where do you get an engineer for that?
Yeah.
We got one engineer who earns a lot more than that, and that's just the way it is here. So it's easy, right? But however, we do pay the scientists in America, the electronics developers in America, the people out of Cambridge. They get paid big bucks, and it takes a lot of money to do serious R&D. The other projects I'm working on after this, I talked to you before, I'll build an oil buoy for you that actually works. Well, I'm going to build a light that will run for 20 years with no consumables, but they're not for the general public. They're going to cost like $500 a shot to do, and military might use it. But to do development work, when I was in the lab in Utah, that cost a frigging fortune. The guys who were backing that, and it wasn't just me working there, was other companies were involved and shared facility. It costs a frigging fortune, whereas here it's a little bit cheaper. Next question.
Does Mark have any time anymore to evaluate energy claims?
Funny you say that. I don't fly around all over the world doing it anymore, but I still do. I still have people email me. First thing they send me is an NDA. and 90% of what I did, I don't, unless I'm traveling, like if I'm traveling to Hong Kong, or there's an inventor there, if I'm traveling to the UK, I do evaluate them, and I closely keep in contact with lots of inventors who are my friends. I'm one myself, I'm not really a good inventor, but I was talking to Tommy Reed last night, and man, that guy, he's at it again. He's got his new Clem engine Model 10, I think we should be up to. And I have many, many other inventors who talk to me regularly each week, and pursuing the free energy quest. And I keep telling them they probably won't get there, but enjoy the journey. So I still do evaluate some technologies. But
we all love Tommy.
Say I'm semi-retired. Yeah.
Yeah.
But we're going to, you and I, we're going to do that in a couple of years, remember, or next year. We're going to zip around the world and have a look at a few. That's my aim.
Yeah. Promises.
Once I get this one out of my hair, mate, I've got another 6 to 12 months hard work here, and then I can take it a bit easier, hopefully.
Somebody wants to know if there's any good prospects on the horizon.
It's a material technology. I think, you know how I saw your eyebrows go about the Orbo thing, whatever, Mark. Mark's keeping the door open. I know a little bit more about what they did, and there are other people with higher skill sets. I won't say higher skill sets. Let's say a bit more, how can I put it? I don't want to say reputable, a bit more serious about the science, working on similar things. But it all gets down to one thing. Where does energy come from? And you've got to answer that question first. Second question, can you self-loop it? That's always one of my favourites. And third one, show me the data. Because most of these people making claims can't read a meter. Look at all the cash people, early days. They're only just starting to learn how to read meters.
Look at all the cash people now.
Oh, look at that wonderful Russian flashlight. It's the battery bounce or battery relaxation, and they're selling them as a free energy device.
Does he have any thoughts about the Aqueon battery technology out of Pennsylvania?
Yeah, great. They're really, really good. Brilliant. Look, here's the deal, and I know but here's the deal with the free energy. Solar is booming worldwide, even in the Philippines here. They got shopping centers here with 10 megabyte roofs on that. They've gone nuts over here. There's a 21 or 22-year-old entrepreneur. He's got 300 or 400 megawatts of projects underway. There's a youngster. It's gone nuts. And wind has gone nuts, but they're missing one thing: cheap, economical storage. For the fluctuations. Mm-hmm. And that's where the Aqueon's good. But if you read the Revolution Green site, it seems every day of the week there's another 5 battery developments, another 5 stories. And I was looking back the last 3 years, how many actually came to fruition? And the Aqueon one did. Now they're moving some of their manufacturing to China, and that's going to reduce the cost dramatically. But they'll keep their project going in Pennsylvania. My only fear for them, they have got a new version that's going to reduce the price. They've got double the power output. Is a lot of these other battery technologies are getting cheaper and cheaper. You watch Elon Musk and his little battery factory when it fires up. You watch, and there's 2 or 3 just as big, if not bigger, in China being built. You watch the price of those lithium ions come down. They'll halve.
Sure. Okay.
Aqueon's good technology, though. Very good. Next question.
I'm looking in the chat room. I'm not seeing a whole lot here. Most of the questions have been coming from 1 or 2 people, and that's about it. So I think at this point, Mr. Dansie, I'm gonna let you go. I want to thank you for joining me on Zero Fossil Fuel channel. I hope my audience found this interesting. If anybody has a project that they'd like reported on, or a widget they've been working on in their garage, please drop an email to zeronews@altenergy.org. I'll post that link in the description below, and we'll see if we can't squeeze that into the weekly newscast. Thanks all for joining me.
One final parting thing.
Sure.
This is a stepping stone technology, okay? It's not the end-all, be-all. The reason for it, my motivation is 1.6 billion people don't have electricity, and they're using kerosene lights. In India alone, 1 million people have burns. The kids have got 10 times the tuberculosis rate who have to breathe in the fumes, and it can cost a fortune for the kerosene. So what I tried to do, and the reason we started this, and we're selling the product into the West, but the real reason for it, it's not a free energy, it's not the end-all be-all. All it's trying to do is be a lot better than kerosene and a lot better batteries. So, all we're doing is a very, very small step, and I think people need to understand that. It's a stepping stone. My next projects, hopefully it helps me fund the next projects to take that little step further, to get closer and closer to where we do discover or find new ways to harvest the environment for energy.
And my apologies.
That's it.
And my apologies for not asking for final closing comments from my esteemed guest here. I'll get it right one of these times.
You're good. You're good, mate. Don't worry about it.
All right.
Take 3.
And that's it for this edition of Zero Fossil Fuel. Thanks all for joining me. Hope you had fun with this interview. I know I sure did. As always, please rate, share, comment, and subscribe to my videos. And peace, everyone.